Hello, welcome to A-Level Physics and Mathematics. In this section, we will proceed with question number 5, which is from exercise 2.1. Question number 5. This is question number 5. We did calculate yesterday about question 4. So we will proceed, like I said, we will proceed with the question 5, which is basically last question. So before I proceed with this session, could you please like, share, and subscribe this video? That will help me a lot. So question number 5, it says that an object projected at an angle theta with velocity of 30 meter per second reached its maximum height in 1.5 second. Okay, and then calculate the horizontal range of this object. Okay, meaning that the range of the object is or horizontal displacement. Okay, that's also horizontal displacement. So that is requested. We basically requested to calculate the horizontal range or the horizontal displacement basically. So to calculate this question, basically, like I said before, we need to understand a question first. Okay, what is appropriate equation that would help me to calculate this given question? Okay, so to calculate this question, basically we need to understand the given term. So as you can see, we have a velocity, which is the initial velocity of an object. So the given terms, let me write over here, given, we do have a velocity, which is initial velocity, is equal to, or v sub o is equal to 30 meter per second, okay, which is 30 meter per second. And then we do have time, right, which is time, which is equal to 1.5 second, and then acceleration due to gravity of this projected object, okay, and which is equal to 110 meter per second square, right? So those are given terms, okay, and then the required is acceleration, the range of an object. So to calculate the range of an object, these are, like I said, these are given terms. Then the required term is basically is r, right? R is equal to the question mark. So to find out the range of this object, we need to know the appropriate equation that will help you to calculate the range of this object. Because it's a projectile motion, so we do have a couple of basic equation, right? You can refer that in a previous video if you are not if you did not if you did not see before, so you can refer the previous video so that you can see for basic equation that will help you any projectile motion equation. Okay, so like I said, the request term is r. So what we can do is we need to know the basic, like I said, basic equation that will help you to calculate the this projectile motion, this object, or the range of this projectile object. So what we can do is, first thing is first, this is a given term, like I said. So as you know, the thing is what we need to do from here. As you can see, this is a maximum height, and then we need to understand something or some basic concept or basic condition to calculate this equation. So as you know, Vy, to calculate this equation, so like I said, as you know, the Vy or the final vertical velocity or the vertical component at the maximum point in the projectile motion is 0, right? Which is Vy is equal to 0. This is a condition that you need to know or you need to understand since it is at the maximum point. So Vy or the final vertical component or the vertical component of the projected object is 0 at the maximum point. That is basically, I believe you're familiar with that. Anyway, that's, I just want to remind that, guys. So basically you will use to calculate the projectile, the range of this equation, you need to use Vy is equal to, we need to use basically Vy is equal to V sub O, right? V sub O sub y minus g time t, because acceleration due to gravity is a downward. So this is a basic equation that will help you to calculate the projectile motion of, the range of this projected object. So as you know from the previous session, like I said, this term will go to 0, and then this guy is equal to 0 is equal to V sub O sine theta, right? Sine theta minus g time t, right? So these terms, I believe you are familiar with. We did discussing this in the last section. So maybe, like I said, you can refer to another video. So from here, as we can see that this term is over here, g and t, or acceleration due to gravity, is over here. So meaning that gt is equal to 1 point, is that 1 point? No, it's 1.5 or 10, right? 10 meter per second, or you can just simply calculate, because you will get the meter per second, right? So 1.5, which is equal to 15, right? 15. So you can plug this guy over here. So which is equal to V sub O sine theta, right? Sine theta minus 1.5, right? Then from here, what you can do is you can rearrange this equation, meaning that 15, or when you rearrange this equation, you will get V sub O. Let me just write over here. So V sub O sine theta, right? Sine theta is equal to 1.5, right? Basically 1.5 meter per second. Okay, you will get a meter per second over here. So from here, we don't have an angle theta or sine theta, so we need to find out an angle or a sine theta, right? So to calculate the sine theta, what we can do is you can divide it both sides by V naught, which is equal to 30, right? So let me rearrange this guy as well. 30 sine or theta is equal to 1.5 meter per second, right? So sine theta from here, sine theta is equal to 1 meter per second over, that it is 30, right? 30 meter per second. So sine theta is equal to it is 0.5, right? 0.5. Yeah, that's 0.5. So now we can get, meaning that from here we can get an angle theta, right? So an angle theta, which is equal to t, is equal to sine inverse of 0.5, right? Sine inverse of 0.5, which is equal to sine inverse of sine inverse of 0.5 is equal to 30 degree. Okay, that is sine theta, because we don't have theta, right? So we did find the theta. Now we can calculate range, right? So from the previous session, as you know that the range of a projectile motion, or the horizontal component, you can calculate the horizontal component using V naught, right? V naught sub x V sub O sub x time t, right? Which is total time or total flight time. So that's a basic equation that will help you to calculate the horizontal range of any projectile motion. Okay, don't forget this one. So from here, basically we will replace, or basically you can get ranges. The range of the projectile motion you will get using right V sub O square, v sub o square sine, right? Sine theta or sine t theta, basically it's supposed to be sine t theta upon acceleration due to gravity. You will get this equation basically using this, meaning that, let me write over here, like I said, range of the projectile motion is equal to v sub or f sub x times t, right? This is equal to v naught sine, right? V naught sine 2, v naught is not a sine, basically it's a cosine, right? Cosine of theta time t means a total flight time, right? Like I say, so you will get a v naught sine of sine theta upon g. So when you calculate this this equation, this expression, basically you will get range is equal to, like I said, v sub o square sine open the bracket 2 theta over what? G, acceleration due to gravity. This is an equation that will help you to calculate the horizontal component, the horizontal range or horizontal displacement of the any projectile motion. Okay, so now we do have all terms, or we do have all parameters. What we need to do, we need to just plug all given terms. So we do have what was that? We do have the initial velocity. So r is equal to 30, right? 30 meters per second, the whole square, time with sine theta, sine theta 2, sine t, sine 2 theta, and then over what? Acceleration due to gravity, right? Which is 10 meters per second square, 10 meters per second square. So first thing is first, you can calculate this first. So what we can do is sine theta, sine 2 theta is equal to how much? Sine theta, sine theta, theta is equal to 2 time with 30, right? 30 degree, which is equal to sine what? 60 degree. Okay, you will get sine 60 degree, and then sine 60 degree means basically it is square root of, or it is square root of 3, right? Square root of, I'm sorry guys, 3 upon 2, or which is approximately, you will get 0.8, right? 86. That is a sine 60 degree approximate value. So you can just plug everything over here. So range of the projected or projectile motion object, projected object is equal to, which is 900, right? 900 meters square per second square. Forget about the unit, because you need to express range in meters, right? It's a displacement. So multiplied by square root of, meaning the sine 2 theta means square root of what? 3 upon 2 over 10 meter per second. You can say meter per second square because of acceleration. So basically, don't forget the unit. Like I said, you need to express the horizontal displacement in meter or any other, like meter or centimeter. But basically, since in the SI unit of displacement is a meter, you need to express in meter. So from here you can cancel this guy, and then you will get 450 square root of what? 3 upon what? 10, right? So which is equal to, from here you can cancel this guy as well, 45. Finally you will get 45 square root of what? You will get square root of 3, right? So from here, square root of 44, square root of 4, or that square root of 3 means time 1.7, let me just double confirm over here, 1.7, yep, 1.732, right? So finally you will get 7 point, right? 77.9 meter. That is the final answer of, like I said, question 5 from exercise 2.1. Okay, these are these are all about this session. So please feel free to put, if you have any question, please feel free to put in the comment section. I'm happy to reply for you guys. So that's all for today. Like I said, please subscribe, share, and then like this video. That will help me a lot. So this is all about projectile motion as well as a projectile motion equation. Next time we will proceed with another topic. I think it is translation and then rotational motion, I believe. Maybe I need to check. Anyway, this is all about today's section. So yeah, if you have any question, please let me know in the comment section. Have a great day. Thanks so much.